Good morning, everybody. This is webinar 2 for April 28th today. There's supposed to be some more people logging on. It looks like people are logging in right now. So again, I'll introduce myself. My name is Bill Gens. I'm the Sales and Technical Director here at TopSolid USA. I'm joined by Joe Hart, our Technical Manager, and Mike Kay, our Sales Manager. They will be monitoring the questions as you guys post them, and we'll do our best as usual to answer any questions you have as we go. So this session, we will be talking about what's new in TopSolid Cam for 2D milling. Let's get to it. All right, so I don't want you to get too excited. There's only a short list of improvements for 2D milling this year. 34 of them, to be specific. Okay, so we're going to try to get through all of these as efficiently as we can. All right, so this first one, again, has to do with analysis of machining features. You know, every year we spend more development time working on helping you guys automate your programming even further. So this year, one of the things we did, and this is actually improvements made by users around the world. So if we go here to analysis of our machining feature analysis, we have a good sized plate here. It's analyzing, and off we go. Now, you can see we have some stuff with machining processes in there and some stuff with methods already associated with it. Some of it's manual machining. So here we can show features without machining processes. We can show features without associated methods. Okay, so these are the two new commands. It's just to help you minimize and find precisely what you're looking for. Cool. Close that one off. Next one has to do with sharp edge management in side milling. Okay, so this had to do specifically with helicoidal side milling, and when you wanted to turn on, and expand this here, when you wanted to break an edge on a sharp corner like this. Okay, in previous versions, it didn't always give the result we're looking for. For those of you not familiar with the command, I'm referring to this command here. Okay, so in 7.16, I believe we have corrected this. So if we go and upgrade that to 7.16, and again, if you open a file created prior to 7.16 and you want to upgrade it, you have to either go here and apply the upgrade, or you can do it operation by operation through the right-click menu here and apply the upgrade. So here I applied the upgrade, and if you watch, now it's breaking the edge appropriately on that helicoidal side. Alrighty, also with regards to breaking edges, it is now possible, and let me back up here, before 7.16, breaking angles in open profiles would only work with truncated contouring, meaning you had to deal with it profile by profile, or feature by feature. The improvement now is that it works with just regular contouring. So you select the one face to machine, because these are all at the same level and there's material, it's going to machine everything. And if we go to our angle management here, you have your breaking edges happening on the lead in and lead out. Of course, you can turn that on and off. That affects everything. And there you go. Next. So we added a new field to side milling to manage the feed rate and spindle rate on the final axial passes. Let's have a look. So you can see we're just doing 2 passes here, right? So we're doing a pass down to there and then a final pass at the lowest level. So if we come into here, let's first look at what our feeds and speeds are. I'm just going to make these easy so it's easy to identify, like so. And now when we go into settings, you have a final axial, and let's expand that so everyone can see, final axial feed rate and final axial spindle rate. So in this case, I want to be 1.5 times larger or faster on my final feed rate and on my final spindle rate. Okay? So if we click OK, and we watch the simulation on this, so right now, we're at 500 millimeters per minute, right? And I'm just going to flip this around so we get to the final depth. Okay? And now, we're at 750 millimeters a minute. Okay? And again, the spindle rate is also going faster. Just like in side milling, we also made this improvement in end milling. Okay? So if we look here, you have, again, the same controls for your final depth of cuts in end milling. Ready? Moving on. So, item 2.6, let's go ahead and open that up. And in this one, it has to do with the control of specific coolants when plunging in material. This improvement has been applied to the end milling command and the roughing command. So if we go to our open pocketing command here, for our plunge move. So if we go to our plunges, and let me expand this just a little bit so it's a little easier for everyone to see. You now have a custom coolant option here, so you can specify the type of coolant you want to use right there. If your control allows you to control the pressure, you can set the pressure settings as well. And that will be a different coolant applied to the plunge from your standard feeds and speeds. Alrighty. Next, we improved the analysis, the topological analysis of grooves, specifically or slot machining. So in cases where you had two slots running into each other like this, in previous versions, the automatic analysis wasn't very good. Okay, so if we look at this toolpath here, you can see it's violating the part here. So you had to go and manually resolve this. So now if we go and upgrade this, and then regen, now you'll see that problem has been resolved. And this was caused by when the end condition wasn't a full circular arc like this, so it didn't know how to terminate. So it terminated at the end of the feature right there. So now we can take into consideration partial arcs. All right. Let's go to item 2.8. All right, so in previous versions, in 7.15 and prior, when selecting to ignore the bottom radius, the finish shape management also became inactive. Now, by default, TopSolid keeps the finish shape management even when the bottom radiuses are selected to be ignored, and a silhouette calculation is done above the bottom radius to ensure the protection of the part. Plus, then you also have the ability to manually tell it to not take into consideration the finish shape or not. Let me show you what I'm referring to here. So if I go into my facing operation here, and we go ignore the bottom radiuses, now, again, you're getting a nice clean result. If you then turn this off, of course, yes, it's going to face everywhere and collide with everything, but that was the results you were getting when you turned off ignore bottom radius before. Now you're getting a much cleaner result. Alrighty. .9, chamfering with a sketch. This is just a little one. Again, this was a user request. Flip this up. Don't need that one. Basically what the improvement is in the geometry altitude is accessible for each wireframe geometry now. So you can position the machining of the wireframe through geometry area. So what does this mean? If you need to make an adjustment here, you come into your sketch, you go to your machining. You can either double click to get into here, or you can hit the select machine and select the wrench, whichever. And then you can set it to whatever altitude you need it to be. Okay, so there you can see I shifted everything. It could be a plus or minus value. It's just a way to give you more control. Again, this only exists when you're using profiles to guide the chamfer machine. Righty. Let's move on to item 2.10. Manufacturing feature analysis, detecting contour manufacturing features. All right, so if I go into here and we go into analysis, or machining feature analysis, pardon me, you will now see that a contour machining has been found. Okay, so this is new this year. We didn't have contour machining before, but this is because of a new feature that I'll introduce in a little bit called contour roughing. So therefore we can rough automatically using that routine from the outside of the part in using contour roughing. Or even if there's just a little bit of stock on the outside of the profile and you want to automatically machine it with contouring or side milling. Okay, so that's a new improvement. With the fact that that exists and you can find that now, you have the ability in your process documents, okay, machining process documents, to define items for roughing versus finishing. And then in your association documents, you can then assign to that specific process for external contour and roughing, the process that you want to use or the method you want to use. Plus, under default methods now, there is a default method for contouring even. So you can assign a default methodology there so that by default, even if you didn't assign one, it's going to pick this default methodology. Perfect. Alrighty, let's go down to 2.11. And this is an end milling improvement. It is to respect the plunge point when simple geometry optimization is active. Maybe some of you have run into this. So here I'm doing this pocket. Under my settings here, I have simple geometry optimization active. On top of that, I have specified my own plunge point. Okay, so double click, that was my plunge point. And what you'll see that it does is it then plunges there, and then it will walk over to the beginning of the toolpath, and off you go. Okay? And again, if I show you this in that one, you can see it's doing this because simple geometry optimization is for circular or square type of shapes. And of course here, same concept. It's respecting the plunge point even though it's nowhere near where it's starting. So you can get it to do what you need it to do. Okay. Next. This one's actually kind of nice. This is an improvement to end milling and side milling. Okay. It's to allow a draft angle for pocket and contouring. Okay. So, for example, my pocketing here. If I go into my pocketing, you can see it's just pocketing straight up there. However, I can go into my settings. You had a stock to leave on the wall shift before with a value, but now you can actually type an angle. So for example, I want that to be 10 degrees, and now you can see it's stepping away appropriately based on that angle. The same thing exists. Go to another sample here. That's still just pocketing. Just showing the updated stock, but the same thing exists if we were to go to side milling. You had value before, you now have angle as well. So you can just step down the wall, following the natural angle of the wall. Perfect. Next, a nice improvement in the end milling algorithm. With regards to the high-speed machining options and non-alpha loops. So, for example, when The management of, this is especially visible in cases of tool paths where step overs are greater than 70% and generating loops around 90%. All right, what do I mean? If we look right now we have our facing and we are set at a 100% step over, right? So it's making these weird, crazy loops here. If I upgrade this, and again, this is for old toolpath, and we re-execute it, now you can see it cleans up that action. Okay, I do the same thing on the next facing. This is at 95%. We'll upgrade it, and then we'll execute it, and you'll see again, cleans it up nicely. This one now is at 90%. We're going to upgrade it. We'll re-execute, and again, nice and clean. And then this one here is the open pocket, right? You can see it's got all sorts of little loops all over the place there. Again, it's a 70% step over. Let's go ahead and upgrade that. And we'll execute. And now that's all cleaned up as well. So again, it's just an effort to make cleaner motion for you when using non-alpha loops. Okay, and just to show you, I'm in this mode here. Okay. All right, this next one, I think many of you will like. It's an improvement to side milling to allow you to stay at the same altitude if possible, meaning no clearance. So in side milling, we implemented the possibility to create a link between curves of different altitudes respecting the length between two passes. So what do I mean? So first of all, this is cleaning out all the corners. And if you look, I'm coming around and then moving down to the next altitude cleanly, coming around, and so forth, so on. Now, how does this work? I go into my side milling, and I go to my settings, and we go to our high-speed machining options. You have the option stay at same Z level if possible. So if I turn that off, now it goes back to the way it was, which is toolpath, pick up rapid, come over, toolpath, pick up rapid, come over, and you have a lot of wasted time in rapid. So this by itself gets rid of all of that motion. Now, something to be aware of. By the way, it's controlled by this distance. So you have to play with this distance sometimes to get what you want. This is the minimum length for these link movements. Now, in this case, I'm machining these corners with a tool that has the same size radius as my corner radius. Because of that, okay, I have added into my settings here for my compensation diameter a small little movement. That small little movement is what's adding a little bit of a radius here so that we can generate the turn versus bury the cutter. Now, because of that, if we look at this straight down, you get motion like this because it needs to shift the tool path. Okay? It's still gouge free, but you're still making kind of a hard angle move there, right? So if you don't want that, get rid of this extra movement here. But in this corner, you're going to have a sharp corner because it's a size for size tool. So the only way to not have that sharp corner, obviously put a smaller tool in, right? But now if we look at the link movement there between each depth of cut is extremely fast, extremely efficient, and extremely smooth. On top of that, you can control the feed rate here. Right now it's set to maximum feed, but maybe you don't want it to be at maximum feed because it's small movements. So if your main feed rate, I don't even know what I said in this one, let's go look. My main feed rate is 540 millimeters a minute, okay? So maybe in here, I want to set a factor, all right, and we'll be 120%. Just be 20% faster, okay? But at the end of the day, you now have extremely nice control over movement like this. Now, where this does not work is in helicoidal, but in helicoidal, you're going to get your complete profiles anyway, okay? So So the link between toolpaths, is it posted as rapid feed or regular feed? If a regular feed, can you control the feed? Boom. Well, I think I answered all those questions without realizing it. So, perfect. And I agree, this is a huge improvement. It will simplify things extremely. Alrighty, let's go on to 2.15. All right, this is a little one on Boost. This is just to show you that we're always working on things. Currently, the cycle time on this is 10 minutes, 30 seconds, roughly. Okay, if we go ahead and upgrade this, and before I do, look at the toolpath. Okay, and now I'll recalculate it. Now we're down about a minute. Okay, 9 minutes, 26 seconds, something like that. All right, and if you look, toolpath's a little bit different now. So we have spent some time tweaking the algorithm of boost milling, trying to see if we can make it machine even faster for you guys. You just got to remember, if it's a 715 or older, you have to upgrade it to the new algorithm to take advantage of this. Okay, next. I think some of you will like this as well. This feature was not available prior to 716 for 2D milling. Okay, so end milling and side milling, collision detection for 2D milling. We have now added the ability. First of all, you guys know what the red dots are. That means that my tool's not sticking out far enough, and I'm going to beat the hell out of my holder, right? So if you notice, we now have the collisions tab here that is normally in 3D and above toolpath. It is now available in end milling and side milling. And we can come in here and say, you know what, I want to say 2 millimeters away from everything. It's going to recalculate. And now you can see the toolpath down there is stepping away so that the holder can fit down there. The thing to remember, whenever you're doing end milling, side milling, it's exact math calculation. So if you guys are using custom holders, make sure your custom holders are defined properly. The spun profile is as simplified as possible, because if you have a really complex profile for your tool definition, it's going to add to the calculation time. So just keep that in mind. So if you turn this option on and it's taken a long time to crunch out for you, go back, check your tool definitions, specifically your holder definition, to make sure you don't have a lot of crazy extra curves in there that you don't need. And obviously, if you have issues, reach out to support. We'll help guide you through it. Perfect. Okay, next improvement is an improvement with regards to, in the side milling command, with regards to reducing feed rates in angle. So in previous versions, decreasing feed rates in the angles or radiuses were done in some unjustified cases, such as on the lead-in and lead-out. Now the decreased feed rate won't trigger when the radius or angle is in the lead-in or out. Okay, so right now you can see by my reduced feed rate colors, my pink colors there, it's happening on the lead-in, lead-out, which is kind of silly. So if we come in here and we upgrade this, all right. In this case, when you upgrade it, it resets the command. So you do have to come in here and turn it back on. Pardon me, I was in the right place. So we're going to go to here, do that, and we're going to say 6 millimeter minimum radius. Recalculate. And now you can see staying in my standard feed rate everywhere it's supposed to be and just reducing the feed rate in the corners. Perfect. Alrighty. Now, next one. Again, this just has to do with machining feature analysis to find outside silhouettes. So if we go here and we go to machine feature analysis, as long as you have a direction reference, meaning we want to focus the area based on that direction and refilter. Okay. then you're going to get the nibbling profile or the outside profile of the part that you can apply a methodology to. If you don't do that, and I should have started there, minimize this so we can see more. Go back to here. Because right now I'm on a 5-axis machine, so it can technically see machining on all sides of the part, right? This is why we added the improvement to say, only based on this direction, do the analysis, and then it gives you that nibbling profile. And hopefully you guys are seeing, we're doing a lot of work on the automation side now. So, all right, I like this one. So, end milling, when you're finishing the bottom of a pocket, right? Or the wall of the pocket or island walls without lifting up the tool. In the high-speed machining tab, find the link without retraction checkbox. Excuse me. Too much talking over the last few days. So right now we're finishing the bottom, right? And right now you can see we're even doing little micro lift-ups between here, but we're still picking up the tool and hopping all over the place. And we'd like to keep that tool down and engaged and just walk over. So let's take a look at how we do that. We'll open this up. We'll go to our settings. Okay. And again, this is under high-speed machining. And you have a new option right here, link without retraction. Watch your toolpath out here when I turn it on. All the rapids go away, and all the movements are now done at the same altitude of the face we're finishing. Thanks, John. Now, you have more control than that, okay? For example, you can see here, first of all, the blue is your max machine feed. You can control this to be however you want it to be. You can use max machine feed. You can choose to have a factor of your program feed. You can do whatever you want, okay? The other thing you can do is you can go to the, I'm going to say it's the plunge area, and you can play with your peripheral safety distance. So if I make this greater, watch what happens. Now notice it's going around objects versus high feed rate through the center of objects. Okay. Personally, I like the high feed rate through the center of objects because it keeps operators on their toes. However, some people don't like that, so you can play around with this value all you want. Okay. Again, I think this is a really nice improvement for helping you to control the tool's location between cuts. Alrighty. Just a little note, this doesn't work with boost milling today. So if you activate boost milling, you won't have this control. But I don't think you're going to finish the floor using boost milling, so I think it's okay. Okie dokie. Speaking of boost milling. Alright. Brant's had a sample, my sample's better. So I'm going to load up my sample instead. In boost milling, you can now specify a feed rate in the mixed milling direction toolpath. What does that actually mean? Let's go in here. Again, we have a feed rate for our boost milling of 250 inches a minute or whatever, doesn't matter. If I go into my settings, when I activate boost, you now have used mixed milling direction. Well, you always had that, okay? But when you activate the mixed milling direction, you now have the ability to set a different feed rate for the climb cutting, or pardon me, the conventional cutting, okay? Now, from here, what happens? So I'm setting it just in this sample to be slower, right? So if we go look at this, and again, you can see it by the color. The yellow is the program feed rate, the pink is the adjusted feed rate. And if we go and simulate this, get down into our feed rate, 250, 125, 250, 125, okay? So you're seeing that you have the control to play with the feed rate in these cases. All right, perfect. All right, so I told you there was a new type of roughing available. It's called contour roughing. So let's take a look. I'm just going to remove all of these. Okay. So contour roughing works from the profile found to the extents of the stock. It's the nature of the beast. Okay. So for example, if I choose this face and I go to side milling, or not, pardon me, side milling, contour roughing, watch what happens. It goes from that profile out to the extents of the stock. If I have any of you that were using version 6 of TopSolid Cam, we had this command in there back then. It's finally made its way back into TopSolid 7. Okay. With this methodology, of course, you can also activate boost machining. So you can use adaptive machining if necessary there. So that's the first sample of how to use it. The next sample of how to use it. Again, if I go here, we'll do it up here, why not? If I go here and do contour roughing, it's everywhere there's material to the Z level of that face that I selected, right? So we're getting it in all those places. That's another way. Yet another option. Let's go turn on some sketches. If I use this sketch here and go to contour roughing, it's just using that as a bounding profile, and it's grabbing everywhere to the altitude of the sketch, which is at the deepest point there, to do roughing from the stock to the part. Okay? And then one of my favorite samples, if I use Alt selection. So if I hold Alt down, select this face, and go to contour roughing, it's going to be localized to that feature only. So you have a lot of control over how it's generating the profiles to machine and the areas to machine. And don't forget that subtle little Alt selection methodology. Cool. Alrighty. So this next one, so end milling default values driving the type of plunge. In 7.15 and prior, for customers who set the default plunge strategy to direct, and as TopSolid selected a previously created side mill without center cutting, the result would lead to a change in the plunge strategy, thus not respecting the selected default strategy. The goal of this enhancement is to let the default values drive the strategy of plunge and improve the user experience. So if in default values, plunge setting is set on direct and plunge authorized, and the selected tool has no center cutting, the user will get a message. Okay? I don't remember if I have this set correctly on mine, but I do. There you go. It's right there. Direct plunge allowed with a tool without center cutting. So it's warning you that yes, we allowed you to do it, but based on the definition of a tool you selected and the options you selected, if you really put this tool in the machine, you're going to have issues. Okay? So it's a little thing, but again, and maybe I'll take a quick note here. For those of you not aware of this, or that you forget this, I would always have your event manager activated and visible somewhere. This is like the Windows event manager. So anytime you get a message down here, we re-execute this, you're going to get it down here as well. So if you don't have this turned on, and to turn this on, of course, that's the user message. So if you didn't have that turned on, you wouldn't know that your toolpath did something maybe you shouldn't do. Okay? So if you didn't have your event viewer on down here, you would have no idea. But I would have at minimum this turned on so that you understand that, okay, there's a warning, we need to go check it. Make sure we did something correct. Okay? Alrighty. So this one doesn't have a sample, it's just here, so I'm just going to read the example to you. So in 7.16, it is technically possible to deactivate the computation of silhouettes in end milling. This can be useful in very specific cases for customers doing a certain range of operations. Silhouette calculations are done during the topologic analysis to determine the final geometry to machine, and also for each Z-pass when the silhouette calculation is adjusted to the stock. In some cases, it can be preferred to work without silhouettes. For example, in the case of a very high face count part, where the finished machine zones could be defined directly by the selected face. Prior to using this possibility, be sure to check the following. Activate default values, TopSolid Basic, no stock management, or finish environment, collisions, etc. Deactivate the preview of the toolpath. Deactivate the graphical preview of the machine zone. The faces to work with on your part are all cleared on the sides, devoid of risk of collision, and they're contouring to find the machine zones by themselves. To summarize, this improvement is done for companies that are, or customers that are doing massively big parts. So it allows you to turn off a lot of the automation that we use on our day-to-day parts so that you can get your toolpath generated relatively quickly. Okay? All right, let's keep on going. Couple samples here. So in side milling, compensation set on original mode. So compensation in original mode would work with overcuts on lead-ins and outs, break-in edges, and some other parameters in specific cases. The calculation of compensation mode has been reworked. Again, this is a calculation thing. I don't know that it's, I'm not even gonna worry about this one because you may have never seen it and it's just some better math. We're gonna keep it that way, okay? All right, boost milling and slot milling. So boost milling was made available in slot milling and adapted for some specific cases. So let's go look at our slot milling. You have access to more parameters than the usual tricoid strategy, such as tool engagement. So let's go into here and have a look. So we can do it by tool engagement. Okay. You can either have a fixed step over or do it by tool engagement. The engagement is there to just make a better nibble at things. Okay. Again, to use this, you have to have the boost milling license, of course, but now you have the ability to use it inside a slot mill. Alrighty. So a couple of other improvements to boost milling just while we're talking about them, and I'll bring this little document over so you can see what I'm reading. Boost performance improvements. In 7.16, we've improved the global performance in terms of operation time for boost by changing the way lead-in and outs are calculated during the boost cycle. The helical lead-in and out movement, shown in light blue, to reposition the tool between lateral passes has been improved to be short as possible while still respecting two important parameters, the lead-in and out radius in the boost tab and the peripheral safety distance in the plunge tab. Okay, so these two things. The resulting radius will be superior, if not equal, in respect to these values. If the reposition distance is too large to be reached during the helical movement, the algorithm will add a vertical jump in Fmax. So here you can see it's picking up for safety. All right, Q28. Oh, nope, Q28 doesn't have a sample. Again, we'll look through this one. So, step over check. It is possible as TopSolid to check for tool overload. This is kind of nice. This is, again, a really nice feature in 228, or in, in 7.16. There's those words again, John. They're hard. As the boost toolpath should respect the step over everywhere, we implemented a routine to check for tool overload. It is available in 2-axis and 4-axis and 3D and 4D roughing. Okay, so you can see here, this is in a accuracy of this check. None gives no check at all. Rough gives an alert when tool overload exceeded by 100%. Standard is 50% overload. Fine is 20% overload. Okay, obviously, as you go to the fine, it will add to the calculation time a little bit more. Okay. Perfect. Where the overloaded parts of the toolpaths are now highlighted in magenta as well. So this way, you know specifically where these conditions are happening. This one is super obvious. Okay, I think this one was from a bug, to be honest. But here you can see the tool is basically burying itself in material, which, yes, that would be quite an overload. All right, so keep going here. Down to 2.30. I don't remember if that one's got one. Goody, it does. Let's go look. Like I said, there's a lot of improvements this year in 2D. So this is end milling last step over management. So it is now possible to request to change the last step over for an end milling operation. Okay. So if we go into our toolpath here, you now have the last step over. Okay. And that's right here. So maybe we have 10%, 10%, and now you can see we have a 50% step over as the last one. Okay? Pretty nice. Okie doke. So 2.31 is, with regards to end milling, it's better environment management. Okay? And here, I'm going to bring this over so you can see what I'm looking at. This is the way it was before, so we could see this would roll over. This is the way it is now. And just because we're running long on this, I'm going to just progress on to the next one. This one has to do with 2D milling, retraction feed rate management. Again, there's no sample cam file for this one, but it's not really needed. It's now possible to manually change the retraction in the case of the direction of retract strategy. So you can see here on the retract, you now have an up feed rate, and you can switch from rapid to whatever you want. Okay. And then next we have end milling Z tangency clearance. This one's kind of cool. So, for our open pocket here, notice the move here? So instead of it just being a direct plunge move, you now have, and this is controlled in your retract, you now have a Z tangent clearance. Okay? For now, for those of you who may ask the question, is that going to be output in G17 or G18? No, because we never know where it's going to be currently and what angle on the machine it's going to be at. So right now it's a linear interp movement. I believe an improvement request exists already to force it to be out in G17 or G18, or pardon me, G18 or G19, just to keep the code simpler. Okay, but you have a radius and you have a height. It's a much smoother way to come off the machine anyway, or off the part. Ready. Last step. So in end milling, well, we have two, but we do. We have an island contouring at the earliest option. So if we come into here and we go to our settings and we go to our integrated contouring, you now have the option contouring of islands at the earliest, which just means it's going to do the islands first, I believe. Okay? Yeah, that's all it does. It says, let the user choose to machine the islands at the beginning versus at the end. Truthfully, for my metal users out there, no one's going to do this. I believe this option was added for TopSolid Cam. But there you go. Alrighty, so that brings us to the end of what's new for TopSolid Cam with regards to 2D milling. Make this official. There you go. Does anyone have any questions that didn't get answered or need to be answered?